afternoon, everyone. I am Ermaline Iscago, and this afternoon I am going to discuss what is a polynomial function and a rational function. So, a polynomial function is a function that can be expressed in the form of polynomial. The definition can be derived from the definition of a polynomial equation. A polynomial function, it can be written in the form p of x is equal to a sub n, x raised to n, plus a sub n minus 1, x raised to n minus 1, plus ellipsis, plus a sub 2, x raised to 2, plus a sub 1, x plus a sub 0, where a's are all real numbers called the coefficient of the polynomial. The polynomial is generally written as p of x, and the highest power of the variable of p of x is known as our degree, or the degree of the polynomial. So for example, we have p of x is equal to 4x cubed minus 3x squared plus 2. And number 2, we have p of x is equal to x raised to 7 minus 4x to the 5th plus 1. And number 3, we have p of x is equal to 4x squared minus 2x minus 4. And in another box, we have here p of x is equal to 5x raised to negative 2 plus 1. And p of x is equal to 4x raised to 1 half plus 3x plus 1. And in number 3, we also have p of x is equal to the quantity of 9x plus 1 divided by x. Now, observe these examples. What can you say about the exponents of these given functions? So, in the first set of examples, these examples are examples of polynomial function, while the other set is not a polynomial function. Why? Because a polynomial function only have positive integers as exponents. In polynomial function, we cannot have negative exponents, we cannot have fraction as exponents. So, we will only consider the positive integers. Okay. So there are some types of polynomial functions. First, we have zero polynomial function. So zero polynomial function, sometimes called constant function. So this function is written in the form p of x is equal to a is equal to ax raised to 0. And the another is linear polynomial function. So linear polynomial function can be written in the form p of x is equal to ax plus b. Okay. Next is we have quadratic polynomial function. Quadratic polynomial function is written in the form p of x is equal to ax squared plus bx plus c. Then, we have cubic polynomial function. Cubic polynomial function is written in the form p of x is equal to ax cubed plus bx squared plus c plus cx plus d. And then, the last one is quartic polynomial function. Quartic polynomial function is written in form p of x is equal to ax to the 4th plus bx cubed plus cx squared plus dx plus c. Now, the details of these polynomial functions will be discussed along with its graphs. Okay. So, the graphs of a polynomial function depends on its degree. No? So, we have here first the zero polynomial function. What is the graph of a zero polynomial function? For example, we have p of x is equal to 4. So as you can see, we have a constant, 4. So the graph of p of x is equal to 4 is a horizontal line. A horizontal line that passes through a point of 0, 4. Okay. Next is the graph of a linear function. For example, we have p of x is equal to 2x plus 3. So in linear function, the b here, 3, represents as our y-intercepts, and a, which is 2, is the slope of our line. So the graph of a linear function is a line that passes through a y-intercept and having a slope of 2. Graph of a quadratic polynomial function. So graph of a quadratic polynomial function. So in quadratic polynomial function, we call its graph as parabola. So parabola is a curve that with one extreme point called the vertex. It is a mirror symmetric curve where any point is at an equal distance from the fixed point known as the focus. So in the quadratic function, we have quadratic polynomial function. The constant a here represents the wideness of the parabola. And then as a decreases, the wideness of the parabola increases. So, since we're going to find the vertex of a parabola before we can plot our graph, to find the vertex of a parabola is given by hk is equal to negative b over 2a and negative d over 4a, where d is the discriminant and it is equal to b squared minus 4ac. Or it could be written as hk is equal to negative b over 2a and 4ac minus b squared over 4a. So that is the formula in getting the vertex of our parabola. And let us also remember that if a is greater than 0, our parabola opens upward. And if a is lesser than 0, the parabola opens downward. Now, let us consider this example. The graph of p of x is equal to x squared plus 2x minus 3. So this function, using the formula, we can get the vertex of this parabola as hk is equal to negative 1, negative 4. And then, this function, as we can see, our a here is 1, and 1 is greater than 0. Therefore, the parabola opens upward. And then, in another example, we have p of x is equal to negative x squared minus 2x plus 3. And our a here is negative 1. Therefore, the parabola opens downwards. And then the vertex is 1 and 4 using the formula. So this is now the face of our graph. Okay. The one that opens upward is the graph of x squared plus 2x minus 3. And the one opens downward is the graph of p of x is equal to negative x squared minus 2x plus 3. Okay, let us continue with the graphs of a higher degree polynomial function. So, the graph of a higher degree polynomial function depends on the degree. If p of x has degree n, then any straight line can intersect it at a maximum of n points. So, example, the constant term in the polynomial expression here represents the y-intercept. So, the constant represents the y-intercept. For example, we have P of x is equal to 4x to the fourth minus 2x squared plus x minus 2. So, our y-intercept is negative 2. Therefore, as you can see in the graph, the y-intercept is a negative 2. And there is a straight line that intersects in exactly 4 points. So, since the n here is 4, the degree of our polynomial is 4, therefore, we have a straight line that intersects in exactly 4 points. So, let us now proceed to rational function. So, what is a rational function? A rational function is a function in which can be written in the ratio of two polynomial functions. So, any function of one variable x is called a rational function if and only if it can be written in the form f of x is equal to p of x over q of x, where p and q are polynomial functions of x and q of x is not equal to 0. Okay, so in rational function, we will be dealing with the domain of a rational function. So the domain of a rational function, f of x is equal to p of x over q of x, is the set of all values of x for which the denominator q of x is not 0. For example, we have f of x is equal to 1 over x. So the domain is comprised of all values of x except 0. Then, okay, another example. We have f of x is equal to x squared minus 3x minus 2 all over x squared minus 4. So the domain of this function includes all the values of x except where x squared minus 4 is equal to 0. So we have here x squared minus 4 is equal to, we're going to factor x squared minus 4. So we have x plus 2 times x minus 2. So we have x is equal to negative 2 and x is equal to positive 2. So meaning the domain of this function includes all the values of x not equal to negative 2 and 2. And also in rational function, in graphing rational function, we will also be dealing asymptotes. So let us first define what is an asymptote. An asymptote is a straight line which a curve approaches arbitrarily closely as it goes to infinity. And there are some types of asymptotes. First is we have vertical asymptote. So vertical asymptote occur at singularities of a rational function or points at which the function is defined. This means that the graph will have a vertical asymptote at x is equal to a if the denominator is 0 at x is equal to a and the numerator is not 0 at x is equal to a. So that is the vertical asymptote. And then we also have horizontal or oblique asymptote. And the existence of horizontal or oblique asymptote depends on the degrees of the polynomial in the numerator and the denominator. Okay. If n is greater than m, okay, then there is no horizontal asymptote. However, if n is equal to m plus 1, then there exists as slant asymptote. And if n is lesser than m, then the x-axis is the horizontal asymptote. And then if n is equal to m, then a horizontal asymptote exists, and the equation is coefficient of the highest power in a power term in the numerator over the coefficient of the highest power term in the denominator. Okay, so let us now proceed to graphing a rational function. In graphing a rational function, first, we have to find the intercepts, if there are any. Remember that the y-intercept is given by 0, f of 0. And we find the x-intercepts by setting the numerator equal to 0 and then solving. Then, the next step is to find the vertical asymptotes by setting the denominator equal to 0 and then solving. Next is find the horizontal asymptote if it exists. And then the vertical asymptote will divide the number line into regions. In each region, graph at least one point. This point will tell us whether the graph will be above or below the horizontal asymptote. And if we need to get several points to determine the general shape of the graph. Next. For example, sketch the graph of a function f of x is equal to 3x plus 6 over x minus 1. So first step, we're going to find the intercepts. So the y-intercept is f of 0 is equal to 6 over negative 1. So that is equal to negative 6. Therefore, our y-intercept is 0, negative 6. Then, the x-intercept is, we have 3x plus 6 is equal to 0. So, we have here, x is equal to negative 2. Therefore, our x-intercept is negative 2, 0. So, the next step is to find the vertical asymptote by setting the denominator equal to 0. So, we have x minus 1 is equal to 0. So, x is equal to 1. Therefore, our vertical asymptote is in x is equal to 1. And then, we've got one vertical asymptote. So, this means that there are now two regions of x. So, they are x is greater than 1 and x is lesser than 1. And then, find the horizontal asymptote, if any. So, in our example, we can find a horizontal asymptote since the coefficient of the highest power term in the numerator is greater than the coefficient in the highest term in the highest power term in the denominator. So, we have y is equal to 3 over 1. So, our horizontal asymptote is in y is equal to 3. Now, we just need points in each region for x's. Since the y-intercept and the x-intercept are already in the left region, we won't need to get points there. That means that we'll just need to get 1 point or a point in the right region. It doesn't really matter what value of x we pick here. We just need to keep it fairly small so it will fit into our graph. So, for instance, we're going to pick 2 as a value of x. So, we have f of 2 is equal to 3 times 2 plus 6 over 2 minus 1. So we have, the result is 12. So we have now a point 2, 12. So for our graph, this one, the form of our graph, and always remember that the asymptotes are shown in a dotted line. Okay, so that's all for today. Thank you and have a great day.